Hi guys, good evening. Can you hear me? Hello.
Yes, sir.
Yeah. Yep. Yeah, we'll start session. So yesterday's class, day 2, 5 p.m. Day 2. Yes, all the Java history discussed. Second day class, what is Java? Yes, when the Java was released, that history discussed. That features, that history 1995 to today, what was happened with Java? That all that history discussed. Java contents discussed. Like what is SE, what is interpretation, what is mobilization, what is effects. These things were discussed. Next about our syllabus discussed. Java standardization, Java technology. About our syllabus discussed. Okay. Next, what is a framework? About frameworks discussed. Yes, purpose of Spring and Hibernate frameworks discussed. What do the big data frameworks discussed? Okay. Yes, what is presentation of Java also discussed. Okay. Yes, by the year 2010. 90% of existing applications are migrated to Java. Regions discussed. Okay. Yes, now Java is leader in the market. Various all the regions discussed. Present position of Java discussed. So okay, here millions of Java resource requirements. Okay, crores of Java resource required. Present region, all that very clearly. That analysis explained here. Okay. Yes, next today topic is Java features. Let us start with Java features. Java features. See JDK 1.0. See JDK 1.0. Yes, once again. Still anyone unable to hear me? See anyone is unable to hear me? Yes, rejoin the session. Please rejoin the session. Rejoin the session. Just rejoin the session. If anyone unable to hear me, just rejoin. Rejoin the session. Okay. Yes. Anyone unable to hear me, please rejoin the session. Just rejoin. Anyone unable to hear me, just rejoin the session. Okay. Almost is online only. Yeah, this girl has to join. Yes, sorry, God. Has to rejoin. Yes, you're fine. Yes. Now let us start. Yeah. Today topic is about Java features. So let us start Java features. So yesterday's class that history discussed. Yes, yesterday topic about complete Java history discussed. Yes, today Java features like independent of platform, portability, group language, scalability, and security. These are the all Java features. Okay, one second. Just one second, taking some water. Yes, independent of platform, the JDK 1.0 first version of Java. JDK 1.0 first version of Java released with main features. Released with main features as below. First one independent of platform, portability, group language, scalability, and security. Okay. See, to understand all these features, you must have some basics. Yes, to understand all these features, some basics knowledge required, some basics required. Yes, you need some basics to understand. Okay. Yes, to understand all these features. One second. Yes. Still anyone unable to hear me? Rejoin the session. Rejoin. Rejoin. Yes. If unable to hear me, rejoin the session. Just rejoin. Yes. If anyone unable to hear me, just rejoin the session. Rejoin. Fine. I hope everyone is online only. Yeah, fine. Yes. Let us start. So yesterday all the history completed. Day 2. Yes, day 2. Actual classes started. Java. What is Java? Yes, the Java history. First version of Java release. Yes, these features and that all the Java history discussed. Next about Java, different Java contents about standardization, enterprise, mobile, and effects, and all that Java contents discussed. Java history discussed. Next, what is present position of Java? Present position of Java also discussed. Means past discussed, present discussed, and future also. Okay, so those things completed yesterday. Yes, today topic is Java features. We'll start with Java features. Yes, so this is today topic. Today topic. Okay, today topic is this one here. See JDK 1.0, first version of Java, released with main features as below. JDK 1.0 is a first version of Java, released with main features as below. First one, independent of platform, portability, OOP language, scalability, and security. Yet these are the initial features. Later, so many features added. Yes, those features, versionalized features, we'll discuss next. Okay, so these are initial features. Okay, see, independent of platform portability. Yes, to understand these features here, you must have some basics, some basic knowledge. So once you have that knowledge, then easy to understand all the features here. Basics like about OS knowledge, about operating, yes, about operating systems, about OS, what is OS? Next about interpreter, yes, about interpreter and compiler, about interpreter and compiler, compiler. Next exe file, about exe file and dot class files. Okay, yes. Apart from this, next low level languages, and high level languages. Yes, and high level languages, Yes, if you know all of these things, then easy to understand Java. Yes, before going to Java, before going to all these features here, first let us see about all these basics. What is OS? How OS is working? Okay, when you're running Java program or C program or C++, when you're running some programs, how OS is behaving, that behavior. Next, what is interpreter? What is compiler? Okay, how they are working here. Next, what is exe file? What is dot class file? Next, apart from low level language, high level language. Once you have this knowledge here, then easy to understand Java. So before going to Java, yes, let us start with basics here. See, I'm starting with basics. Starting with basics here. Yes, very starting from the scratch. Yes, non-IT background guys also can understand these basics here. Okay, non-IT background. Yes, not only non-IT background here, even IT background guys also there are some basics. These basics are unknown facts. Yeah, these are unknown facts. Even guys who are having 10 years of experience also, they don't know about these basics. 10 years of experience of guys who is having 10 years experience, even that case also don't have these basics here. Yes, starting from very basics. See, computerware. Yes, yes. Computerware. What is computerware? See, I'm starting from very basics here. I think is not expected this much of basics. Very scratch. Computer were basically two categories. Yes, hardware, and second one software. Hardware and software. Yes, hardware. These are physical components of a computer. Yes, hardware. These are physical components of a computer we can touch. Hardware parts you can touch. They are physical components you can touch, like keyboards, mouse, monitor, motherboards, hard disk, RAM, all the hardware components. We can touch all these parts. Okay, this is not our part. We are the software engineers. We are the software engineers. So let us start with software. Our part is software. Let us start with software here. So what is a software? Software. In software, yes, everything is a program. Everything is a program. In software, everything is a program. Yes, in software, everything is a program. 1 second. Yes, in software, everything is a program. Yes, it's a collection. Yes, it's a collection. 1 second. 1 second. Hello. 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 Yes. So what is software? Software, yes, it's a collection of programs. It's a collection of programs such as C++, yes, Java, Python. Yes, there are different programs. It's a collection of programs. Okay, software. In software, everything is program. It's a collection of programs. See, software basically two categories. Basically two categories. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. System software. Next is application software. System software and application software. Software basically two categories. First one, system software. Next is application software. Yes, what is system software? Yes, system software. Yes, it interacts. It interacts with hardware components. System software interacts with hardware components. Interacts with hardware components. Example, OS, operating system. Operating systems comes in this category. Operating systems and device drivers. And device drivers. Device drivers comes in this category. System software. Yes, system software it interacts with hardware components. System software it interacts with hardware components. Example OS and device drivers. Operating systems and device drivers comes in this category. Okay. Yes. Yes. So it interacts with hardware components. See example operating systems. Operating systems interacts with hardware device drivers also to communicate with hardware components. Next, application software. What is application software? See application software. Yeah, this is for the purpose of application development. Application software. Yeah, this is for, for the yes purpose of application development for the 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 purpose of application development. Yes, see application software. Yeah, this is for the purpose of application development. Application, what is application here? See apps. See see in our daily life we are working with many applications. Yes, you guys tell me some examples in our daily life. Yes, in our daily life, working with many applications. Anyone idea? Yes. See, in our daily life, we are working with many applications. So, what are the applications using? Yeah, banking application. Okay, good. Ranjit Sapu. Banking application. Next, it's that banking, internet banking. It's application. Next, any other applications? Social media applications. Okay, good. Yes, IRCTC. Okay, good. Okay, gaming. Okay, next. Anything else? Yes, everyone is in common used one. Facebook, right? Best example, Facebook. Facebook, its application. Facebook, yes, social media apps. Facebook, Facebook. Yes, next WhatsApp. Yes, WhatsApp, Facebook, WhatsApp, Twitter, Twitter. Their applications. Flipkart. Okay, food delivery apps. Okay, next trading applications, online trading apps. Next banking applications, company websites. These are the applications. Okay, these are all the applications here. Yes, how to done? Yes, even go to meeting, go to training. These are applications. Zoom app. Go to training, go to meeting. These are applications. Online shopping applications, food delivery apps. Yes, all these applications here. So how to develop this kind of applications here? To develop this kind of applications, we need some software, right? Yes, to develop these applications. To develop these kind of applications, we need some softwares. Those are called applications. Okay. To develop such kind of applications, we need some software. Those are called applications. Yes, example, Java. Java is a mostly used application software. Java is the highest used application software, mostly used application software. Java, yes, next .NET. .NET is application software. .NET is application software. Next Python is application software. Python. Next Hadoop. Hadoop is application software. C language and C++. They're application softwares. Yes, next databases. Databases. Yes, all these application softwares. Okay. See, in software, we have many technologies. More than 100 technologies we have. Just like languages, more than 100 tools. Sorry, more than 100 technologies. Like languages, whatever it is, maybe languages, okay, maybe some tools. Yes, maybe some packages. Packages. Yes, many technologies, many tools, many languages, many packages, different kind of things we are using here. Languages. Yes, language like Java, C and C++, Python, C Sharp, like it's different languages. Tools like warehousing tools, testing tools, reporting tools. Next, yes, AWS tools, DevOps tools, Hadoop tools, big data tools, like that. Many tools. We are using different tools here. Packages like SAP, Oracle, ERP package. Next, MS Office, Tally. Yes, like this, different packages. Like this, many things there is. So exactly which is application software. See exactly which is application software. Exactly which is application software. See what is system software? It interacts with hardware components. That means only voice interacts with hardware. Others will not. Many technologies. Only voice interacting. So except voice. Yes, of course, these device drivers are part of voice. Device drivers also part of voice here. Part of voice. See operating systems. See here. See except voice, all are application softwares. See here except. See except operating systems. All are application softwares. Simple. All are application softwares. All are application software. All are application softwares. Yes, except voice. See except voice, except operating systems, all are application softwares. Simple. What is application software? This is, yes, this is for the purpose of application development. Okay, this is for the purpose of application development. Okay, one second. Yes, you guys, my voice, is it clear? My voice? Are you understanding clearly? Hello. Yes, anyone can respond. Okay, fine. Yeah,
Yeah, yes.
Shobha, yes, try to rejoin. Yes, yes, Kollur Shobha. Yes, check your system volume. Check your system volume. Check your system volume. Check your system volume. Or this rejoin. Or rejoin. Okay. See, everyone is fine here. Everyone is Everyone is fine. Fine. Everyone is fine. Yes, only issue from your side. Okay. Yes. Yes. See except ways. See except predictions, all our applications, all our applications are this. Yes. See guys, notes is not necessary. Running notes is not necessary. Here, yes, you guys don't try to write running notes here. It's not necessary. Okay. Yeah, everything prepared in documents. Very clearly prepared documents. So this is your document. 25th Feb updated document, recently updated document, and this is see today topic. Yes, from the scratch. Today from the scratch started. Okay. Yes, sir. So here introduction to software. Yes, it's a collection of programs such as C programs like this. Software basically two categories: system software, application software. The same expand here. Same thing expand here. So except ways all our application softwares. Same point. Every point prepared in the document here. Even single line or single word is not missing. Everything. Yes, this document is same as my order of explanation. Yeah, this document same order. Even single line also no mismatch. Everything is matching. Everything as is matching here. Okay. So no worry about class notes. You don't write any class note. Just you follow this document. This document for you only. I'll share with you. This document I'll share with you. Okay. Tomorrow I'll give the drive access to all. Yes. Tomorrow before starting tomorrow class. Yes. Tomorrow by the afternoon I'll give the drive access. So you can access from the drive here. Okay. This record daily recordings and documents and everything you can access from the drive. Okay. I'll share to your Gmail. I'll give the drive access to your Gmail. Okay. Yes. Okay. Fine. Now here. So next here. See. So this is about system software and application software. Yes. This first. Yes. About OS. Yes. We should discuss about OS. See, once you have all this knowledge, then easy to understand Java. See, I can start Java features directly. Okay, but yes, one second. Let me save this today's session. Day one, day two saved. Now day three. Yes, this also I'll share with you. Day one, day two already shared. Day one, day two already shared here. Already shared. Now day three. I'm saving day three also. Yes, this also I'll share it. Okay. Yes. So about ways. Topic is about ways. Yes, what is ways? Yes, let me take Word document for understanding purpose. Yes, easy to explain. Yes, ways operating systems. Yes, about ways. Some question for you guys. Some question. Very simple question. Very simple question. Can we run any program? Any program? Yes, without voice. Can we run any program without voice? Very simple question. Yes, what is answer for this? Very simple question. Of course, I'll explain everything clearly. Of course, I'll explain. Just simple question. Can we run any program without voice? Can we run any program without voice? Yes or no answer. Answer is yes or no. Yes. Can we run? Yes or no. Can we run any program without voice? Yes. Answer is you messed up the guys are responding. Yes. Saying that no, 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 no. Okay. No. No. Good. Thank you
No.
for yes. No. 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 Okay. See, my class are interactive classes. Yes, see, if you asking any question, I'll respond immediately. Yes, I'll check the chat box. Anyone asking question chat box, I'll respond. Okay. Yes, here, if you have any doubts, just share in chat box. Share in chat box. I can see your questions here. I can respond immediately. Okay. Yes, it's an interactive class. It's not one-way class. It's an interactive class. Okay. Fine. So here, can we run any program without voice here? No. Answer is no. Answer is no. Answer is no. Answer is no. So answer is no. We cannot. Okay. See, except except bias, except bias to run all programs, all programs OS requires, OS requires, OS requires. So what is bias? Bias is not a software program. Bias, bias stands for yes basic, basic, yes input, basic, basic input and output, basic input output system. Bias stands for basic input output system. Bias stands for basic input output system. Bias stands for bias. Bias stands for basic input output system. Okay, so what is exactly bias? Bias is a hardware program. Yes, bias. Bias it's a yes, it is a hardware. It's a hardware program. It's a hardware program. It's a hardware program. Bias it's a hardware program. Yes, hardware program. Okay, it's a chip level program. It's a yes, it's a chip level. It's a chip level program. It's a chip level program. Yes. See, in motherboard they say bias chip. Bias chip. Okay. Bias chip. Bias chip. Bias chip. Yes, this is a bias chip. In motherboard this is a bias chip. See, once you power on your computer, first bias starts. Once you power on your computer, first bias starts. Yes, what's the role of bias? What's the task of bias here? See here, bias, yes, it is responsible. Bias is responsible. Bias is responsible to boot operating system, to boot operating system, to boot operating system, to boot operating system, to boot operating system. That's it. Bias. So before going to start with, first bias starts here. That bias is responsible to boot OS here. Booting, what is booting here? Booting. Yes, booting is a process. Yes, booting is a process. See, booting is a process. One second. Yes, booting is a process of loading OS from hard disk to RAM memory, hard disk, hard disk to RAM memory, hard disk to RAM. Okay, yes, here bias is responsible to boot operating system. Booting is a process of loading OS from hard disk to RAM, hard disk to RAM. Okay, so once booting is done, your system is ready. So once OS loaded from hard disk RAM memory, your system is ready. See this, now OS is running. Okay, see before going to start with, first bias starts. Bias is a hardware program, chip level program. Okay, once you power on system, first of all bias starts. Bias starts. That bias is responsible to load OS from hard disk to RAM memory. Now this is OS, right? This is OS. Yes, where this OS is running? Inside the RAM memory. OS is running in the RAM memory. This OS is running inside the RAM memory. So this OS is responsible to take your request. So once, yes, once booting is done, okay, system is ready. System is ready. Okay, see, system is ready. See, our system is like this. Yes, computer. See here, once we is loaded, your system is ready. See here, hardware. One second. Yes, here hardware. Hardware. On top of hardware, yes, operating system. Operating system. On top of hardware, operating system. On top of OS, see application. Yes, one second, sorry. See hardware. On top of hardware, OS is running. So once OS is started, your system is ready. Okay, one system, yes, once you power on system here, first of all, bias starts here. Before starting with, first bias starts. That bias loading OS in the RAM memory. Once OS started, your system is ready. Now this OS is running inside the RAM memory. So once OS is ready, your system is ready. Your system is ready. Okay, yes, see every program running on top of OS only. Suppose C program running on top of OS. C++, all these programs, C program, C++, Java, yes, Python, suppose Hadoop, yes, Hadoop, yes, databases, like this, all they are running on top of OS. These are called as application softwares, right? Application softwares. These are application softwares. Yes, previously we discussed application software. Yes, it's application software. Yes, all these application softwares running on top of OS. Okay, yes, all these application softwares running on top of OS. Okay, so OS it's giving platform, just working like a platform. On top of it all are running. So OS is working like a platform. OS working like a platform. On top of it all are running. On top of it all are running. So OS acting like a platform. So what is operating system? Question is here. What is operating system? What is operating system? See, what is operating system? What is operating system? Yes, first point. Yes, it's a platform. It's a platform. It's a platform. OS, it's a platform. Yes, where we can run, where we can run all the application software, all the application softwares, all the application software. It's a platform working like a platform. So OS acting like a platform. Okay, so OS it's a platform. So OS acting like a platform. On top of it all are running. See, Java features. First one, Java is independent of platform. Platform means here what? OS. Yes, on top of OS, Java program running. So OS is a platform to run Java program. So here platform means OS. Platform means OS. Java is independent of platform. Java working on anyways. Anyways, yes, how Java made us independent of platform. That is next talk. We'll discuss. Wait. Once all these basics completed here, yes, we'll go to this. So once these basics completed, then easy to understand these topics here. So let us finish all these basics. Let us finish all these basics here. So first of all, what is Waze here? What is Waze? It's a platform. Waze is a platform where we can run all the applications software. Okay. See, not only platform here. Suppose C program generating some output. That output simply goes to Waze first of all. C program or C++, Java, something like this. See, these programs are generating output. Output of these programs is first of all delivered to OS and then transferred to output device. Next, it transfer to output device. Okay. See, all these programs generating output. For example, here, maybe C program, Java, Python, Hadoop. These are generating output. So output of all the programs simply delivered to OS. Output of all the programs delivered to OS and then transfer to output device. That's it. Suppose reading input reading. Suppose keyboard. Yes, keyboard data goes to OS. Okay, keyboard data goes to OS. Keyboard data goes to OS to get these programs. So between application software and hardware, this is OS. See, there is no direct interaction between these two layers here. No direct interaction. Okay, 1 second. Let me have some more. Yes, yes. See, no direct interaction between application software and hardware. Between these two, there is OS like a mediator. OS is like a mediator between these two. Means like interface. We can say interface exactly. So OS is an interface. See, it's an interface. It's an interface. It's an interface. Yes, between it's an interface between yes this application software layer. Yes, OS is an interface. It's an interface between application software and hardware components. Application software and hardware components. Hardware components. Okay, next, one more important point in Java perspective. Java perspective, Java point of view, some interesting points. See, in ways this library. Yes, every ways contains library. Unix base library, Linux base library, Unix base library. So what is this library here? Library, yes, it contains all input output functions. Library contains all input output functions. Library contains all input output functions. It's a collection of input output functions. Yes, functions means C language functions. C language functions. See, every ways, almost every ways, all the operations here developed in C language. Unix developed in C language, Linux in C language, Windows in C language, Mac OS in C language. Okay, Solaris in C language, Linux, and all these operations in C language. So these are C language functions. That library contains C language input output functions. C language input output functions here. So every OS has its own library. Yes, using this library, it can communicate between application software and hardware components. Okay, see every OS, see every OS, every OS, every OS has its own library. Every OS has its own library here. Its own libraries. Own libraries. Yes, every OS has its own library. Okay, that's not same. Different operation, different libraries. Every OS has its own libraries. Yes, to communicate. To communicate. Yes, to communicate between yes, this application software and hardware components. Okay. Yes, every OS has its own libraries. Libraries. So OS using libraries to communicate between application software and hardware components. Okay. Next, one more important point. Yes, in Java point of view, one more important point. See, here C program or C plus Java. These programs, all these programs, first of all, links with OS library. Of linking with OS library, then communicates with the hardware components. Yes, it has to link the compulsory here. Yet these programs, C programs, C++, Java, Python, all these programs have to link with OS library. Yes, before going to start execution, so first of all, these programs link with OS library. Yet that linking can be statically linking or dynamically linking. Suppose C and C++ is statically linking. So Java and Python is dynamical linking. Yes, we'll discuss. What is statical linking? What is dynamical linking? We'll discuss. Wait, I'll explain clearly. Okay. Yes. So here every program, these all the programs have to link with OS library of linking, communicating with hardware components. So it has to link compulsory here. Every program, see yeah, this is very important point. Remember this one here. Yes, Java features very useful topic. Okay. Yes, every program has to link with OS library. OS library. OS library. Yes, before going to start. Before going to start execution. Yes, before going to start running or execution. Okay, before going to start running here. Yes, it has to link compulsory here. See, every program has to link. It has to link with OS library. Of linking with OS library, then execution starts. Before running program, first linking takes place. First linking. So these programs have to link with OS library. Of linking with OS library, then program execution starts. That linking can be statically linking or dynamically linking. Static linking, dynamic linking. Next we'll discuss. Wait, we'll discuss. Okay. So this is about OS. Okay, that's all about this knowledge enough. Okay, I think you have not expected this kind of basics. Yes, including bias started. Including bias started. The bias, what is waste, how it's working. Okay. Yes, so this is about waste enough. Yes, about waste is enough. Okay. Yes, next. See our topic system software, application software. See about waste. All the 4 points explained document here. In document I have prepared. Just to follow the document here. Just you can follow. So hardware, on top of hardware OS, then application software. See this, the fourth point also mentioned. Okay, every program has to link with OS library before going to start execution. So this is about OS. Okay, fine. Now here, what is Java? Java is application software, right? Java is application software. Java comes under application software. Java is application software. Now let us start with application software. Yes, about application software. See, in application software, there is a front end and a back end. In application software, there is a front end, back end. So what is front end software? What is back end software? Front end, what is front end? What is back end? Let us see. Front end. See here it is some form, right? Here is some form. Here is a registration form, right? Form. Yes, in this form we filled all the details. We filled all the details and submitted, right? And this form is a front end. This form is front end. This form is a front end. So this form collecting data from erase and storing to some location. This form collecting data from all the attendees. Okay. Yes, Durgasoft. Yes, online team. They will take all the data. Then they will start follow up, right? Okay. Get the data storing somewhere. That location is backend. So where this information storing? First name, last name, email address, phone number, your details filled here, right? Now this data goes to some location, storing at some location. That is called a backend. This is called as front end. So front end, this is interact with users. We are the users. So interacting with us, right? Interacting with users and taking data from users. So front end interacts with users and collecting data from users. Back end is to store the data. Seeker, front end, front end. These are to interact with end users. It collects data from end users and stores in the back end. So front end interact with end users. Okay, back end to store and maintain data. Back end is to store the data. For example, databases. Database like Oracle database, MySQL database. Database are backends to store the data. Next, files. In files also you can store data. Files like yes, Linux files, Windows files, Hadoop, big data files. To store big data using Hadoop files. That's it here. Okay, what is Java? Java comes under front end here. Java is a front end. See, behind of this form, JavaScript or JSP. So JSP program taking this code, this data here. So behind of this form, Java server pages. Means Java program is working. The Java program taking data from us means is a front end. So Java is a front end. Java comes on the front end here. Now let us move to front end. Let us move to front end. See, in front ends, there are language and package. In front end, language and package here. So package is ready-made one, ready to use. Package is ready-made one, ready to use. So what's the language here? Language, in language you should write the code. Languages. Java is a language. Java comes from language here. Okay. Yes. Let us move to language. Java is language. See, the way of introducing. Try to observe it how I am introducing into Java. Introducing into Java. See, computer where hardware, software. So Java comes in software. So started software. Yes, in this system software, application software. Java is application software. So move to application software. In application software, front end, back end. Java is a front end. So move to application software, sorry, front end. In front end languages and package. Java is language. Now moving to languages. Yes, let us start languages here. Languages. See languages. Yes, languages. Yes, what is language? It's a media of communication. Language is a media of communication between two things, maybe two persons or two animals, something like this. Just it's a media of communication. See, software languages. Let us come to software. Software languages. So what are the software languages? Software language. See, in software here, first one, computer understandable language. Computer understanding some language. Computer understandable language. First one is computer understandable language. Second one, user understandable. So we are the users, right? We are the users of computer. We are using computer. So our language, user understandable. See, first one, computer understandable language. Next one, user understandable language. So what here, user understandable language like English language, right? See, user understandable language. For example, Java program. Yes. Suppose some Java program. Suppose this is some Java program. Yes, looking like English language. Java program is like English language. It's a user understandable. That English language is a user understandable. Suppose C program, C program, C program. C. It's also English language. C program, Java, Python. All this looks like English. So these are user understandable languages. User understandable. Yes, what is computer understandable language here? What is computer understandable language? Computer understandable language. Yes, computer understandable language. Yes, it depends. See, it depends. It depends. It depends on. It depends on. Yes, depends on generation of computers. computers. Depends on generation of computers. It depends on generation of computers. Yes, how many generation of computers? Yes, tell me, it's very simple question. How many generation of computers? Yes, computer understandable language depends on generation of computers. That depends on generation. How many generation of computers? How many generation of computers? How many generation of computers here? Yes, 4 generations and 5 generations. Next. Okay, Shobha saying that 4 generations. Supraja, 5 generations. Next. Any others? Yes. Sipra Kumari, 4 generations. See, totally 5 generations. Totally 5 generations. Totally 5 generations. Totally 5 generations. Yes, what is first gen? What is first gen? First generation computer. First generation computers is vacuum, vacuum tubes. Yes, first computer, vacuum tubes based. First computer. Yes, next generation, transistor based. Yes, transistor based. Yes, next generation. Yes, third generation. Yes, is a IC based integrated circuits here. IC based. Next, fourth generation. Yes, what is fourth generation? It's a present generation. Fourth one is totally 5 generations. Fourth generation is a present generation. Yes, what is present generation? Present generation is based on what here? Processor based. Present generation is processor based. It's now we are using processor based computer. Yes, processor based computer understandable language binary code. It's a binary code. This is binary codes. Binary codes. Binary codes. Yeah, zeros ones formats. Zeros ones formats. Zeros ones formats. It's a binary code. Present generation. Fifth generation feature. Feature means don't have much period here. Only couple of years it's coming to market. I think 2024 or 2025 coming to market. Yes, only within 2 years coming to market. So what is fifth generation computer? Any one idea? Feature generation within 2 years only. Within 2 years only. No, database is different. Fifth generation. Yes, right. Yes, run this all right. Yes, AI based. AI based. Artificial intelligence based. Yes. For this understandable language, high level language. It's high level language means English. High level language means English. Yes. AI based computer. AI based computer is high level language. Yes, AI based computer understandable language, high level language English. It can understand English. AI based can understand English here. Okay, for a present generation, processor based. Yes, it's a binary code. Now this is fourth generation processor based. Now we are using processor based. Processor based. Okay, now processor based understandable language. So now currently we are using processor based computer. Yes, its language is binary code. So this language is a binary code. It's in the form of binary code. Okay, this is called as low level language. Computer understand with a low level language. Okay, user understand that English, Java, C programs, C++, these are yes, high level language. Okay, so you get languages basically two categories. First one, yes, low level, yes, low level languages. Second one, high level languages, low level and high level language, low level and high level languages, low level and high level language. First one is low level language, next one high level language. Yes, what is low level language? What is high level language here? Low level language. Yes, it's a system understandable language. Low level language. Yes, it is a yes, it is a system understandable. It's a system understandable. It's a system understandable. It's a system understandable language. It's a system understandable language. It's a system understandable language. Yes, it is. Yes, it is in the form of. It is in the form of. It is in the form of binary code. It is in the form of binary code. It is in the form of binary code. Binary code. like zeros ones format, zeros ones format. Okay, yes, yes, it is called as machine language. Yes, it is called as machine language. It is called as machine language. It is called as machine language. It's called as machine. Yes, it is called as machine language. Is machine language. Next, high level language. High level language. What is high level language? See, high level language. Yes, it's a user understandable language. High level language. Yes, it's a user understandable. User. Yes, understandable. Yes, understandable. User understandable language. User understandable language. It's a user understandable language. It's a user understandable language. Yes, it is like English language. It is like English language. Like English language. It's like English language. Like English language. Okay, like English language. Okay. Yes. See, low level language. It's a system understandable language. Yes, system means processor. System means processor. System means it's a processor. It's a processor. Yes, a processor understandable language. It is in the form of binary code, zeros ones format. Zeros is a processor understandable language. Okay, it is called as machine language. It is called as machine language. Okay, next high level language. It's a user understandable language. Is a user understandable language. Yes, it's like English language. Looks like English language. Yes, some question for you guys. Question. Some question. Which is first high level language? Which is first high level language? Which is first high level language? See, many high level language like Java is a high level language, C++ high level language, C language high level language, Python, HTML, all their high level language. That English language are high level language. So which is first high level language? Yes, which is first high level language? Yes, anyone? Can you answer this? Yes, which is first high level language? Of course, I'll explain. Of course, I'll just I'm asking your idea. Which is first high level language? Yes, which is first high level language? Which is first high level language? C language. C language. Good, good. Yes, thank you for response. C is a yes, C language. C language is a first high level language. First high level language. First high level language. Yes. C language is a first high level language. Yes. Get developed by yes, we have developed C language. C language is a first high level language developed by whom? Who has developed C language? Who has developed C language? Who has developed C language? Yes. Okay, so good. Dennis Ritchie. Right, Dennis Ritchie. Right, Dennis Ritchie. Right, Dennis Ritchie. Dennis Ritchie. Yes, in the year 1972. C is a first high level language. Fine. Okay, so this is about low level language and high level language, generation of computers and all the basics. Okay. Yes. See here, high level language. Yes, C program, C++, Java, all the high level language, right? This high level language has to convert this high level language to binary code. Binary code. Okay, every high level language program has to, yes, every high level language program, this program has to convert into binary code. Convert. Yes, convert into binary code. Yes, we'll convert here. Which one will convert here? Every high level language program. Yes, every high level language program, maybe C program or C++, Java, Python, all these programs, that program has to convert into binary code. That yes, that binary code taken by system then executes. System understandable language. That high level language program, yes, suppose Java program, it has to convert into binary code. Suppose C program, the C program has to convert into binary code. Yes, we will convert here. Which one will convert from high level language to binary code? Which one will convert? Yes, which one will convert from high level language to binary code? Yes, anyone idea? Yes, system understandable language. Which one will convert into binary code? Yes, good. Yes, good. Yes, compiler, good compiler. See, either interpreter or compiler. Yes, interpreter. Yes, interpreter or compiler. Interpreter or compiler. Interpreter or compiler converts from high level language to binary. Yes, converts from high level language into binary code. High level language to binary. Yes, this is very important. Yes, what is computer? What is interpreter? What is compiler? Let us see about this. Okay, so interpreter and compilers. Yes, about interpreter and compiler. What is interpreter? What is compiler? Okay, yes. See all the basics here. See, to understand these Java features, we need to have some basics. Yes, about who is discussed. Now let us see about interpreter and compiler. So what is interpreter and compiler? Okay, yes. Yes, interpreter versus compiler. Interpreter versus what is interpreter? What is compiler? Let us see about this. Interpreter and compiler. Yes, first of all about interpreter. Yes, how interpreter is working. See, interpreter. Yes, for this example, Python. Python script is a interpreter based language. Yes, let us take Python here. Python code. Python script. Suppose some test.py file. Okay. Yes, how this Python script is working. Yes, 1 second. D drive. See, Python script development for this purpose we use PyCharm. This is a PyCharm IDE. In our projects we are using PyCharm IDE. See, now better understanding purpose I'm using simple notepad. Just simple notepad. Simply notepad. Details about test folder. Yes, in this test folder. Yes, I'm writing code. 1 second. Let me delete all this. Yes. Okay, detailed test folder. Okay. Yes, let us write some Python script here. In dtrace test folder. So go to command prompt cmd. Command prompt. Yes. D colon D drive. That will take D drive. dir secret test directory. The test directory. cd test change of directory. cd test change of directory. Test directory. Nothing. Zero files. No files. Zero files. 0 bytes. Okay. Here. See that no files. No files. No Python. Yes. Notepad. Notepad. Test.py. That Python script file. Test.py. Yes, open here. Yes, I'm writing very simple script. Just to explain about interpreter, I'm writing very simple script here. A equal to 10. Yes, B equal to 20. Suppose C equal to A plus B. So A equal to 10, C equal to, yes, C equal to 10, B equal to 20, C equal to A plus B. Yes, print, print, yes, addition. Yes, addition equal to, yes, C, displaying C value. Yes, C equal to A minus B. Yes, subtraction. Next subtraction. Print, print, subtraction is equal to subtraction equal to C, displaying C value. C equal to next A into B. Multiplication. Print. Yes, multiplication equal to, yes, multiplication. Multiplication equal to, yes, C. Multiplication equal to C. So very simple script. Save, save and exit. Save and exit. Yes, now go to command prompt. Dir. Here you can see test.py. How to run? Simply Python test.py directly running. Directly running script. Suppose if it is C program. In C program, first of all, you have to compile the program. Means checking for errors. But in Python, no. Directly running. Yes, program executed. Program executed. The program executed. No errors checking. Yes, nothing. Directly submission then execution. Okay, yes. How this Python script is working means interpreter. How that interpreter is working. Yes, let us say about interpreter. How that interpreter is working. How interpreter is working. So this is Python script. Python script. First statements. Suppose A equal to 10. Next B equal to 20. C equal to A plus B. Print addition equal to C. Okay, next C equal to A minus B. Okay, next print. Yes, subtraction. Next C equal to A into B. Next multiplication. Yes, output. Suppose say let us this is Python script or any interpreter based language. Any interpreter based language. How interpreter is working here? See interpreter checking for the first statement. Suppose first statement is correct. Interpreter checking for the first statement. Suppose first statement is correct. Simply the statement converts into binary code. The statement converts into binary code like a zeros ones format. Zeros ones format. That binary code is given to processor. So processor taking that binary code, generating output. So next checking for next statement. Checking for next statement. Suppose next statement also correct. Next statement also correct. Yes, it converts into binary code. If the statement also converts into binary code. Okay. Yes, given to processor, then generating output. See here. Suppose first statement is correct. Immediately converts into binary code and generating output. See next coming statement may be right or wrong. Interpreter never think about next coming statements. Interpreter, that may be Python interpreter or HTML interpreter or JavaScript interpreter, any interpreter. That interpreter never checking for next coming statements. Yes, if the statement is correct, immediately converts into binary code. That binary code given to processor, then giving output here. So converting then execution, next statement checking, conversion then execution means first line completed, first line correct, execution completed. Second line correct, execution completed. So line by line, first line, next line, so line by line. Suppose something wrong here. Something wrong. Suppose something wrong. Interpreter stops. Once any something wrong with that, interpreter stops. Let me show that. Same thing. Yes, notepad. See, suppose here's some mistake. First mistake. Okay. Suppose next here's one more mistake. Yes, here one more mistake. There are three errors actually. Three mistakes. Save. Save and exit. Control yes for save. 1 second. Yes, now run it here. Yes, error at 7th line. Yes, have only one error showed. It's not showing all the errors. Only one error. 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 Just only one error. This is. So only one error. Okay. Now let us correct this mistake here. Let us correct this. Hello. Class. Yes. So this statement. Okay. Correction after correction. After correction. Yes. Save and again run it. Yes. Again next line error. 7th line correction. No, one more error. That means showing only one error. Actually, there are three errors. There are three errors, but showing only one error. There are three, but showing only one error. Showing only one error. Okay. Yes. Now let us correct this also. This mistake also. Correction. Yes. After correction of this mistake, no submit again here. Yes. Again next error means only one error. So interpreter shows only one error. Any error comes, interpreter stops. Any error comes, interpreter stops. Save. And exit. Yes, if no errors, then execution. Yes, execute output, right? That's it. This is working of interpreter. Any error comes, simply stops. So this is about interpreter. Okay. Now let us see same thing compiler. How compiler is working. Yes, when come to compiler, yes, how compiler is working. Let us see about compiler. 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 For compiler, C language. C is a compiler based. C, let us take C language here. Suppose test.c program. Yes, how it's working. C program. Yes, if it is compiled, how it's working here. Compiler checking for the first line. Suppose first line no error, fine. Yes, even correct. It won't convert into binary code immediate. No, it won't convert into binary code. No, it won't convert. It won't convert. Checking for next line. Suppose next line also correct. No, it won't convert. Even correct, it won't convert immediately. Checking for next line. Suppose something wrong. It shows error at third line. After that, then checking for next line. Checking for next also. Even error coming, checking for next line also. Next line also correct. Checking for next line like this top to bottom. Compiler checks whole program from top to bottom. Yes, compiler checks whole program from top to bottom, and shows all the errors. Yes, all the errors from top to bottom, from top to bottom. Suppose this is correct. Okay, next. Right, it shows all the errors. Yes, compiler shows all the errors from top to bottom. See, compiler checks whole program from top to bottom. See, compiler checks whole program. Compiler checks whole program from top to bottom and shows all the errors. Okay, let me show that. C program example. C program example. C program example. See, this is C program. C program. Compile. Yes, success, no error. Run. Is executed. Enter first number 10, second number 20. Addition, subtraction, multiplication. Okay, here are the same program, same example. Yes. Now here, let us do some mistakes. Suppose semicolon missing here. Suppose here bracket missing. Okay. Some missing. Suppose here comma missing. Okay. Suppose here semicolon missing. Yes. Suppose here double quotation missing. Okay. Yes. Suppose here this bracket missing. Okay. Yes. Suppose here semicolon missing. Suppose this bracket missing. Yes. Now save. Saved. After saving, now compile. See this compile errors. All the errors from top to bottom. See, totally 9 errors. Errors 9. Press any key. Errors 9. Press any key. Yes, the first error. Second error. Yes, foot. Yes, see at the bottom. You can see all the errors. 14th line error. 18th line error. 22nd line error. 25th line error. Yes, 29th line error. 29th, 33 line here. Okay, next. 38th line error. 40th line like this, top to bottom. Yes, compiler shows all the errors from top to bottom. It shows all the errors from top to bottom. Now we should correct all the errors. Correction. Okay. Yes, compiler shows all the errors from top to bottom. Compiler shows all the errors. Interpreter is only one error. Interpreter is only one error. But compiler is all the errors from top to bottom. Yes, semicolon. Okay. Yes, next here. Double quotation missing. Okay. Yes. Okay, let us compile. Yes, still some more errors. 3 more errors. See, 33 line errors for this line error. Yeah, this is here semicolon. Okay, next here brackets. Okay, now save it again. Saved. Yes, overwriting. Yes, compile. Success. 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 Program successfully completed. Success. Okay. Yes, compile. After compilation, yes, if no errors, what happens here? See, compiled. Suppose no errors. Compiler shows the all errors from top to bottom. Compiler shows all the errors from top to bottom. Yes, suppose if no errors, what happens? Correction. After correction, if no errors, then what happens here? Everything is fine. Everything is fine. No errors. If no errors, then what happens? Let us see. Okay. Yes, compiler show. Yes, it checks the all statements from top to bottom. Yes, it checks the all statements from top to bottom. Checks the all statements from top to bottom. Okay. You're checking all the statements from top to bottom. 1 second. Yes. So compiler checking all the statements from top to bottom. Suppose if no errors, what happens here? See, if no errors, so this is program. Yes, compile, no errors, success. See, math.cpp. this file, backend. Let us go to backend, C drive, turbo C, yes, bin, yes, that math. See, math.cpp. Yes, modified 6:14 p.m. 9/3. Okay, today date. Just now modified 6:14 p.m. Okay. Yes, now here. Yes, after compile, now run it. Alt run. Now running. See when you're running, so this file generated application. What is this file? Yes, 616 just now generated. What is this file here? Properties, check it, exe file. The exe file generated. Yes, if no errors, then compile opens another error. Sorry, compile opens another file. It opens another file. Yes, if no errors, everything is fine. Compile opens another file. It converts whole code into binary formats. Whole code into binary formats. Zeros ones formats. Whole code into binary formats. Okay, that complete code into binary top to bottom, all lines converts into binary format. Right to yes, another file. That file is called exe file. Exe means executable file. That exe file given to processor. Exe file given to processor. So processor taking exe file, generating output. Okay. Yes, if no errors, compiler checking complete program top to bottom, top to bottom. If no errors, generating one exe file, generating exe file, that exe file executes. That exe file executes. Yes. Now exe file is working. 10. Yes, 20. Yes, addition, subtraction, and multiplication. That's it. So this is difference between compiler and interpreter. See what is main difference? Exe. Exe file is a main difference. Okay. Yes, let us see the differences here. Yes, interpreter versus compiler. The differences. Yes, for a better understanding purpose, let us compare. Let us compare. Yes, interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. Interpreter versus compiler. See interpreter. See interpreter. Yes, checks the code and executes line by line. So this is line by line, right? Line by line. Line by line. Yes, what is compiler? Yes, whole program from top to bottom. Yes, whole program from top to bottom. Whole program is from yes, top to bottom, from top to bottom, from top to bottom, from top to bottom. Okay, so interpreter checking line by line, but compile is whole program from top to bottom. Okay, yes, next here, interpreter, it shows only one error. Yes, it shows only one error. 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 Okay, compiler, yes, it shows all the errors. It shows all the errors from top to bottom. From top to bottom. Yes, all the errors. See, interpreter, it shows only one error. It shows only one error. Okay, yes, compiler, it shows all the errors from top to bottom. All the errors from top to bottom. Okay, so interpret is only one error, but compile is all the errors from top to bottom. Next, important points. Yes, it does not generate exe file. Yes, compiler generates exe. This is the main difference. Next, interpreter. See, interpreter directly the source code executes. The source code. Yes, this program is source code. This program. What are the programs we are writing? That is called a source code. Source code. Okay. So you can interpret it executes source code directly. It executes source code directly. It executes source code directly here. What is company? Exe file executes. Exe file executes. Not source code generating one exe file. That exe file executes. Okay. See, interpreter based language, these are scripting language. They are called a scripting language. These are scripting. Python is a scripting language. Yes. Compiler based, they are programming language. They are programming language. These are programming language. Programming language. Programming language. They are programming language. Okay. Scripting language, programming language. Compiler based is a programming language. Compiler based language called as programming language. Interpreter based called as scripting language. See, for these examples, for these examples, for this example, Python. Python is the best example of scripting language. HTML is scripting language. JavaScript is a scripting language. Okay. Yes. Next, PHP is a scripting language. Yes. Next, Perl is a scripting language. That's scripting language. Yes. Compiler-based examples. C language. Compiler-based examples. C language, C++, and .NET C hash. Right. So interpreter-based language, compiler-based language. See here simply interpreter-based language. See interpreter based language don't have exe file, don't have exe file concept. Yes, here everything is exe file. Yes, exe file working. Exe file works always here. Exe file. Yes, this is a difference. Okay. Yes, you guys some doubt here. Yes, this trainer is always talking about everything, but not talking about Java. Exactly what is Java here? See, interpreter based examples, compiler based example. That's okay. What is Java? Is it interpreter based or compiler based? Yes, what is Java? Yes, we should discuss about Java. What is Java? Yes, is it interpreter based or compiler based here? What is Java? What is your idea? Of course, I'll explain. What is Java. Is it interpreter based or compiler based? Yes, Java. Yes, Java depends on both. Depends on both interpreter. Yes, interpreter as well. Interpreter as well. Compiler. Yes, the topic tomorrow we'll discuss. I'll explain. Yes, I'll explain. Why Java depending on both interpreter as well compiler. See today topic. See your document. See running notes is not necessary. Okay, running notes is not necessary. See, running notes is not necessary. Since today's topic, all these basics today, software languages like low level language, high level language, and all these explained. Interpreter compare the differences. Yes, what is Java? This is tomorrow topic. Okay, tomorrow. Yes, today don't have much time to cover this one. Tomorrow we'll discuss about what is Java. So tomorrow starting with Java concepts. So what is Java? Is it interpreter based or compiler based? Okay. After you have an independent platform topic and exe file .class file definition. Yes, tomorrow topic is very important. Tomorrow we are going to discuss about independent platform. How Java made us independent platform. The Java internals we are going to discuss. Okay. See, tomorrow class don't miss it. See you guys. Yes, maybe joining into my batch or not. That is secondary, but don't miss tomorrow class. See, you may be joining into my batch or not. That is secondary. Leave about it. But tomorrow, don't miss it. Most important topic here. Okay. See, tomorrow topic, no trainer will explain like that. That kind of concepts I'll explain here. And even no website also. No website in the world will explain that kind of concepts here. Yes, you'll see tomorrow. Tomorrow just to attend and see that. Okay. No trainer, even no website in the world